Hello students, welcome to the maths class. Last time we have seen the questions of remainder and factor theorem. Means basically we found two types of questions. One, how to find out the remainder of a given polynomial, and how to prove or how to verify the given value of polynomial is a factor of another polynomial. So now let us start some more questions based on the remainder and factor theorem. Mainly we shall work out on factor theorem wherever the factor is given, and some questions are given which are based on remainder theorem also. So let us see some questions based on that. First question I am taking here. As you can see, the first question is given: using factor theorem to verify x plus a is a factor of x to the power n plus a to the power n for any odd positive integer. Okay, means we have to prove that this is x plus a is a factor of this polynomial. Okay, with the help of factor theorem we can easily prove it. First of all, we shall suppose the value of p of x is equal to x to the power n plus a to the power n. And second thing, I am supposing here the value of q of x. So what is the value of q of x here? X plus a. P of x and q of x, normally we are supposing to show who is my dividend and who is my divisor. So p of x is my dividend here and q of x is my divisor. As you know that when we are finding the remainder, if p of x is divided by q of x, then the divisor normally we kept equal to 0, and then we find out the value of x. That value of x we keep in p of x and we find out the remainder. Here one more thing we will add: if remainder comes equal to 0, we say that qx is a factor of p of x. Okay, so let us proceed the first step. First step is let the divisor q of x is equal to 0. Okay, so what is the value of q of x? I have value of q of x is x plus a is equal to 0, or else I can say the value of x is equal to minus e. So now let us find out the remainder. So therefore I can say that value of remainder is equal to p of which value of x I got here? Minus a. So I can put up here minus e. Right? Now we shall find out the value of p of minus e. Now see, here I am just finding the remainder. If the value of remainder comes 0, I can say that yes, the q of x is a factor of p of x. Okay, so let us find out the remainder. If I want to find out the value of p of minus a, so in p of x I keep the value of x equal to minus a. So see, x to the power n it is coming, so it is minus a whole power n plus a to the power n. Okay, now you read the question that I have left for this situation only. For any odd positive integer n, means n is given here any odd value like 1, 3, 5, okay, something odd number is given to us, and you know that if the minus sign comes under the odd power, remember I have told you earlier also these things, if minus sign comes under the odd power, minus sign remain as it is. If minus sign comes under the even power, minus sign gets eliminated. So here I can say a to the power n will become a to the power n only, and along with that minus sign will come because minus sign is coming under the odd power. And then remaining term is a to the power n, that I am writing as it is. Now you see both the terms are same, they will be cancelled. So I can say that my remainder is coming here equal to 0. So we can say therefore qx is a factor of p of x. Now let us see quickly the another question. Now the next question is given to us: if kx cube plus 9x square plus 4x minus 10 is divided by x plus 3 and it leaves the remainder 5. Remainder is given non-zero term, means x plus 3 is not a factor. Then we have to find out the value of k. First of all, we shall suppose here the value of p of x is equal to kx cube plus 9x square plus 4x minus 10. And the value of q of x, I suppose here as x plus 3. Now I am finding the remainder first. Okay, already the remainder is given in the question, but I am finding the remainder by the method I knows. Okay, so first I will suppose the divisor means qx is equal to 0. What is the value of qx I have? X plus 3 equal to 0, or I can say that the value of x will come here minus of 3. Okay, now let us find out the remainder. So if I try to find out the remainder, then I can say that therefore remainder is equal to p of minus of 3. Okay, because see, the remainder, if I want to find out this value, I will put up in p of x. So now let us proceed further. So remainder will be equal to p of minus of 3, means in p of x I will keep the value of x equal to minus of 3. So k into minus of 3 whole power 3 plus 9 into minus of 3 whole power 2 plus 4 into minus of 3 minus 10. Okay, so everywhere I am keeping the value of x equal to minus of 3. Now let us simplify. So k into minus of 3, minus sign is coming under the odd power, so minus sign will remain. So this will become as minus 27 plus 9 into, now here minus sign is coming under the even power, so minus sign eliminate, and square of 3 will be equal to 9. 4 into minus of 3 will become minus of 12 minus of 10. Little bit more we can simplify. You observe here 12 and 10 we can add, will become 22, and 9 nines are, it will become 81. So finally we shall get here minus of 27k plus 81 minus 22. Okay, but one more thing, from 81 I think we can subtract 22. So if I subtract from 81 22 minus 27k will be as it is, right? And from 81 I am subtracting 22, so 11 minus 2 it would be I think 9, and 8 minus 3 it will be 5. Minus 27k plus 59 is the final value of my remainder, where the value of k is unknown. Okay, so according to me the remainder is coming after dividing px by qx is in this form where k is unknown. And what remainder they are giving to us? 5. So here we can equate both of them because both are the remainder when p of x is divided by q of x. This remainder we found in by our method, and this is the remainder given in the question. So we can say that according to the question we can say remainder is given to us as 5, or we can say that if remainder is 5, my remainder is here minus 27k plus 59 is equal to 5. Now 59 I am sending on that side, so minus 27k will be as it is, and 5 minus 59. 5 minus 59 is equal to minus 54, because signs are different, we can subtract. So minus 27k is equal to minus 54. Minus and minus cancel, 27 will come in division, so 27 is 27 and 27 2s are 54. So what I can say here, the value of k will be equal to 2. This is your required answer in this question. Okay, now 8th question is in the same manner. For the question number 8, I have given you the hint. You try to solve the question number 8 according to the given hint. The 7th and 8th question are nearby same. Only in the 8th question the remainder is not mentioned particularly, while in this question the remainder is mentioned. Okay, I have given you the hint how to find out the remainder in that question. However, the remainder is given in that question, but the remainder is not directly given in the question. You have to find out with the help of property that I have mentioned in the hint. Accordingly, you try to solve it. Now we are taking the next question, that is question number 9. Now let us see the 9th question. In the 9th question we have given that x minus a is a factor of x cube minus mx square minus 2nax plus na square. Okay, then you have to prove that this equation is right. So now see, we will apply the same fundamental and how we can bring it the required things that we will see now. Okay, so first of all, I will suppose this one as p of x is equal to x cube minus mx square minus 2nax plus na square, and the value of q of x I will suppose here as x minus a. Now you know that if I want to find out the remainder when p of x is divided by q of x, then I will take the divisor. This is my divisor, q of x. So that I will take equal to 0. So let us take the value of q of x is equal to 0. So what is the value of q of x I have? That is x minus a will be equal to 0. Or what else I can say? The value of x will be equal to a. Right? Now let us find out the remainder in the question. So what is remainder here? Remainder will be equal to p of a. Okay? Because when you will put the value of x equal to a in p of x, you will get the remainder. So what is the remainder? P of a, if I try to find out. So here in everywhere I will keep the value of x equal to a. So that will be a cube, then minus m into a square. Everywhere I am keeping the value of x equal to a, minus 2n a into the value of x, and again I am keeping here a, and then last plus na square. So last I am writing here as na square. Right? Now here see, remainder we got, actually remainder we have got here. Now one thing is remaining. You see, this remainder we can keep equal to 0. How? Because it is given that x minus a is a factor. Means when you will divide this whole polynomial by x minus a, the remainder will come 0. So here that things only we shall mention, since x minus a is a factor, therefore we can say that the remainder will be equal to 0. Okay, so I am keeping the value of remainder is equal to 0. Now what is my remainder here? Remainder is a cube minus ma square minus, here you observe a and a will multiply, that will become 2n a square and plus na square is equal to 0. Right? Now further, one thing you observe, here I can take the a square common from all the terms, and if I divide the whole equation by a square, so what will remain? If I divide by a square, here a cube is there, so only one a will remain here, minus here I am dividing by a square, so only m will remain. Same way here it will remain 2n and plus n will remain, is equal to 0. If I am dividing by any term, that will be 0 itself. Now observe, 2n and n are two like terms. Okay, so here coefficient of n is 1. So minus of 2 and plus 1, because both are containing n, we can say they are like terms. Okay, so coefficients are here minus of 2 and plus 1. So signs are different. So from 2 I can subtract 1, remaining is 1n, and sign of that 1n will be minus, because bigger term sign I will apply. So this will be a minus m minus 1n, 1 we can leave it, so only minus n I am writing here. Now minus m and minus n we can send on to that side. So this will be a is equal to m plus n. This is your required answer. Okay. Now let us see the next question. It is question number 10. In 10th question, what we have given, if the polynomial 2x cube plus bx square plus 3x minus 5, this is first polynomial, and second one is given here, x cube plus x square minus 4x plus b, leave the same remainder when divided by x minus 2. Means the question is framed in such a way, if you divide the first polynomial by x minus 2, suppose the remainder comes equal to 5, then the same remainder 5 will come when you divide this polynomial by x minus 2 only. So what we shall do it, first of all, we shall find out the remainder in our own terms, okay, as we are finding the remainder. As you can see here also I found the remainder, okay. So that remainder I equated to 0 because it is given the factor over there. In this question, we shall find out the remainder in our own way. Then both the remainder we can equate and we can find out the value of b, okay. So first of all, I will take this one as P1, okay. First polynomial I am taking as P1. So P1x is equal to 2x cube plus bx square plus 3x minus 5. And P2 I am taking here as x cube plus x square minus 4x plus b, okay. And qx, the divisor, I am taking here as x minus 2. Now one by one we shall find out the remainder when P1 is divided by Q and P2 is divided by Q. Since in both the cases divisor is same, so first we can equate the divisor to 0. So let Q of x is equal to 0, or else I can say x minus 2 equal to 0. And finally, what is the value of x I get here? 2, right? Now this value of x, when I will put one by one in P1 and P2, I will get the respective reminders. Reminders means if you are putting x equal to 2 in P1, then you will get that reminder when P1 is divided by Q. And similarly, when x equal to 2 you put in P2, you will get that reminder when P2 is divided by Q. And these two reminders are given same in the question. Okay, so let us find out the two reminders. First, I will say the remainder as R1. Okay, I am denoting the first remainder as R1 is equal to P12, means when P1 is divided by QX, then whatever the remainder I will obtain here, that I am denoting as by P12, because in P1 I am keeping the value x equal to 2. So now put up the value here, 2 into cube of 2 plus b into square of 2 plus 3 into 2 minus 5. Now see, 2 cube is 8, 8 into 2, 16, plus here 4 into b, that is 4b, plus 6 minus 5. And finally what will come? From 6 if I subtract 5, so remaining is 1, 1 plus 16, that is 17. This will be 17 plus 4b. Okay, so this is your value of remainder R1. Now let us find out similarly the remainder R2. Okay, I am denoting it by the symbol R2. That will be. So to find out the R2 means when I am dividing P2 by Q, so this value of x equal to 2, I will keep it in P2. So that will be 2 cube, or we can write down first. This will be P2 and I am putting here value 2. So this will be value of x equal to, I am keeping here 2. So this will be 2 cube plus 2 square minus 4 into 2 plus b. Okay, let us simplify further. 2 cube is 8 plus 4 minus 8 plus b. Minus 8 and plus 8 got cancelled. So remaining is here 4 plus b. Right? Now, according to the question, these two reminders are given equal. So we shall write down, according to the question, R1 and R2 are equal. So what is the value of R1 I have? 17 plus 4b. So 17 plus 4b is equal to 4 plus b. Right? Now that b I can bring it here, this side, and 17 I can send onto that side. So this will be 4b minus b is equal to 4 minus 17. Now 4b, you can subtract 1b, remaining is here 3b. Okay, and 4 minus 17 will be equal to minus of 13 because signs are different, so we can subtract. And finally 3 is in multiplication going on to that side, so we can say that therefore b will be equal to minus 13 upon 3. Okay, this will be your answer. Yes, now see the question number 11 we are going to solve. If x minus 2 and x minus 1 upon 2 are the factors of the polynomial px square plus 5x plus r, then prove that p is equal to r. Students, this question came many times in the examination and sometimes it confused how to solve it. Okay, first of all, you see these two are given the factors. When it is given the factor, then definitely the remainder will come here 0. That you have to remember. So let us solve how to solve this question over here. So let first the given polynomial I am supposing by p of x. That will be here p of x square plus 5x plus r, and these two I am supposing by these two divisor, actually I am supposing by qx and rx. So qx will be equal to x minus 2 and rx will be equal to x minus 1 upon 2. Okay, so these three I have supposed. Now let us find out the remainder when px is divided by qx. So here I am finding the remainder when px is divided by qx. So since px we are dividing by qx, in that case I can say qx will be my divisor. So let qx will be equal to 0. Right? What is the value of qx I have? X minus 2 will be equal to 0. So I can say that the value of x will be equal to 2. Therefore, what will be the remainder here? Remainder I can say that is p of 2, because this value of x I will keep it in p of x. So I will try to find out the value of p of 2. Now let us calculate the value of p of 2. That will be p into square of 2 plus 5 into 2 plus r. Okay, so this will come as 4p plus 10 plus r, right? And this remainder I am taking as, suppose I take it as r1. I give the name as r1. Okay, now let us find out the remainder when the second divisor is dividing p of x. So let us see the second divisor. Here again I am putting one arrow to show you what remainder I am finding here. So remainder when p of x is divided by rx, right? P of x I am dividing by rx. So now my divisor is here rx. I will take it as rx 0. So let rx will be equal to 0, or we can say that what is the value of rx I have? Value of rx I have x minus 1 upon 2 equal to 0. So I can say therefore the value of x is equal to 1 by 2. Now this value again I will keep it in the p of x. So I can say therefore remainder, this remainder I can suppose r2. Okay, I am supposing by r2 will be equal to p of 2, p of 1 upon 2, right? Now put up the value here. So p of 1 upon 2, here I am putting the value. So p into 1 upon 2 the whole power 2, okay, plus 5 into 1 upon 2 and then plus r. Now let us simplify further. 1 upon 2 square will become 1 upon 4 and 1 upon 4 multiplied by p, that will be p upon 4 plus 5 upon 2 plus r. This is the value of r2 I got. Now we come to the given condition in the question. What is the given condition in the question? In the question, if you observe, the condition is given that the x minus 2 and x minus 1 upon 2 are the factors. So when you will divide the given polynomial by x minus 2, the remainder will come 0, and same thing will happen with x minus 1 upon 2 also. So here we will say that the remainder r1 and r2 both are equal to 0. So we can say according to the question. According to the question I can say r1 is equal to 0, or what is the value of r1 I have? 4p plus 10 plus r. So I can say that 4p plus 10 plus r will be equal to 0. This is my equation number 1. Okay. Now further, similarly the value of r2 will be also 0. So and we will keep here r2 is also equal to 0. What is the value of R2 I have? P upon 4 plus 5 upon 2 plus R will be equal to 0. Now to simplify this equation in the form, we will do one thing. We shall multiply the whole equation by 4, because you observe 4 and 2, the biggest term is 4. So normally we shall multiply it by 4. So if I multiply by 4, what I will get here? 4 into P by 4 plus 4 into 5 by 2 plus 4R will be equal to 0. Here 4 and 4 directly cancel. Okay, so we can see that 4 and 4 are cancelled here. Here 2 ones are 2 and 2 twos are 4. So what will remain here? P plus 10 plus 4R will be equal to 0. Equation number second. Now what I am doing here, I am subtracting the equation 1 and equation 2. See, we need to bring P is equal to R. So to bring that required things, we need to do certain manipulations. So what manipulations I am doing it here? Okay, first of all, I am taking equation 1 and equation 2 and I am subtracting second equation from the first. So here we shall write down equation number 1 minus equation number second. What is my equation number 1? 4P plus 10 plus R will be equal to 0. And what is equation number second? P plus 10 plus 4R will be equal to also 0. Now since we are subtracting the second equation, term of second equation sign will be change. Okay, so P will become minus, 10 will become minus and 4R will be also becoming minus, because all three are positive, they will become negative. Now think of, here 10 is negative and here 10 is positive. So 10 and 10 got cancelled. From 4P, if you subtract 1P, this is 1P, 4P, if you are subtracting 1P, remaining is here 3P. Similarly, here coefficient of R, I can take it as 1. Okay, so observe, here also 4 is given and here 1 is given. Signs are different because sign of 4R is minus. Signs are different, so from 4, I will subtract 1. That will remain 3R, but sign of 3R will be negative because bigger term sign I have to apply. Is equal to 0. 3P will remain as it is and 3R will go on to that side. So 3 and 3 got cancelled. We can say that P will be equal to R. This is your answer. Clear? Very good question in the examination. Many times it has come. Okay, so please prepare. You solve this question by your own, then only you will be able to solve in the examination as well. Okay, now let us see the next question, next and last question of today's session. Now let us see the next and last question of today's. Polynomial P of x is equal to x cube minus 2x cube plus 3x square minus ax plus b, and it is divided by these two another polynomial x minus 1 and x plus 1. Definitely if we are dividing this polynomial by these two, so we will get the remainder. If remainder comes 0, we can say that they are factor, but here the remainders are given non-zero, means they are not factor. In that case, we need to find out the value of a and b. So let us see how we can find out. First, we have the value of P of x is equal to x to the power 4 minus 2x cube plus 3x square minus ax plus b. That is given in the question. And suppose we are going to suppose here the value of q of x is equal to x minus 1 and the value of rx is equal to x plus 1. Now let us find out the remainder when P of x is divided by qx. So I am writing here P remainder when P of x is being divided by q of x. So for that I will take the value of q of x equal to 0, or we can say that value of q of x, how much I have, x minus 1 is equal to 0, or we can say the value of x is equal to 1. Now this value I will put up in P of x, so I will get the remainder. So here I can say that remainder I am supposing by R1 and that I will denote by P of 1. right? Because this x equal to 1, when I will keep in p of x, I will get the remainder. That remainder I am supposing by r1. Now let us find out the value of p of 1. So if I put up the value 1 to the power 4 minus 2 into 1 to the power 3 plus 3 into 1 to the power 2 minus a into 1 plus b. So if I simplify, 1 to the power 4 is 1 minus 1 to the power 3 is 1 and 1 into 2 is 2 plus 3 minus a plus b. 3 plus 1 4, 4 minus 2 will remain here 2. So 2 minus a plus b. This will be the value of R1. Okay. Now let us find out the value of R2. R2 means when p of x will divided by Rx. So now I am again putting one arrow to show I am finding the another remainder. So remainder when p of x I am dividing by Rx. Right? So now for that I will take the value of Rx is equal to 0. What is the value of Rx I have given here? X plus 1. So x plus 1 is equal to 0, or else I can say that x will be equal to minus 1. Right? Now the remainder we can say in that case remainder that I am denoting by a symbol R2 will be equal to p of minus 1, because when this value x equal to minus 1 I will keep in p of x, I will get the value of p of minus 1, and that is my remainder. Now further if I go, so p of minus 1 value I will find out. So we can say that therefore the value of R2 will be equal to p of minus 1, x equal to minus 1, I will keep it in the polynomial. That will be minus 1 whole power 4 minus 2 into minus 1 whole power 3, then plus 3 into minus 1 whole power 2, and then minus a into minus 1 and plus b. Okay. So this I am keeping as it is. Now let us simplify. This will be, so value of R2 will be equal to minus 1 to the whole power 4. Since power is even, it will become positive. This is 1. Here power is odd. Okay, power is odd. So minus sign will remain. That minus sign and this minus sign will be multiplied and remaining is 2. Similarly, here minus sign will eliminate. So 1 into 3 will be equal to 3. And minus plus here, this is plus a plus b. Okay, so what I am getting finally here, 1 plus 2 plus 3, that will be 6 here. So we can say that the value of R2 will be equal to 6 plus a plus b. Now according to the question, the reminders we have given here 5 and 19. So we can say that according to the question we have R1 is equal to 5 and R2 is equal to 19. So let us put up the value of R1 and R2. So we can say therefore if I put up the value of R1 in this equation, so I can say that 2 minus a plus b will be equal to 5, right? And if I send 2 and a onto that side, what I will get here? I will get the value of b. b will be equal to 5 minus 2 plus a. So that will be 3 plus a. This will be, I can say b is equal to 3 plus a will be my equation number 1. And similarly, the value of R2, if I keep it here, so I can say and 19 will be equal to 6 plus a plus b. Put up the value of b also. Okay, so if I put up the value of b over there, so 19 is equal to 6 plus a plus 3 plus a, right? So 6 plus 3 is 9, 9 you can bring on this side. So 19 minus 9 will be equal to a plus a will become here 2a. So we can say therefore 2a will be equal to 10. Therefore value of, what is the value of a here? Value of a will be equal to 5. This is your first value we got. Okay, now see the second one. How shall we find out the second one here? See, to find out the second one, what I will do, this value of a, I will keep it in equation number 1. Okay, it is better, I will do it here. So I will get some space. So let me rub this one. So here I can say that the value of a I am keeping in equation number 1. So therefore by equation 1, if I keep in equation number 1, so b will be equal to 3 plus a, means 3 plus 5 will be equal to 8. So at last I can say, hence the value of a will be equal to 5 and b will be equal to 8. So we have finished the question number 11, and now in this question some more topics are remaining, like factorization of quadratic polynomial, cubic polynomial, then application of algebraic identities. So we shall do it one by one, each and everything. So you finish till question number 11 today. 1 or 2 questions are homework. Okay, that question you also finish. Along with them, I have supplied you the assignment. In that assignment, all the questions are written. In the assignment, all the questions taken from the NCERT book as well as from the reference book. So no need to do the separately the question at the last. Okay, so along with the topic only, we are doing all the questions together. So next time we shall see some more questions from question number 12 onwards. Okay, thank you.